Good morning and welcome to Neurology, Embryology Part 2. So today we'll be going all the way till the formation of full brain, right? So without any delay, let's start. Ha, uh, 2, 3 emails, they were about the revision part. We'll do the revision today. So what is expected from you? Say this is what we did in part 1, right? What I am expecting is that you should know 3 things very properly. One, neural tube, the formation of neural tube, right? Second, the neural crest, right? Neural crest, that neuroectoderm. Third, those lateral plates of mesoderm, right? So those lateral plates, in any case, we'll be talking about all of them, and the notochord. And the notochord. If you know these things, fine, nothing to worry about, because today it would be extremely easy, right? All you need to know is that where exactly is that notochord is formed, right? How it is formed, how it functions, right? It was the signaling system. Notochord was the signaling system, right? Neural tube and the neural crest, vital thing just to remember. Tube forms CNS, crest forms PNS, peripheral nervous system. Neural tube forms presynaptic autonomic fibers. Neural crest forms postsynaptic autonomous fibers. True, right? That's the thing which you must remember. Rest is all as we proceed, right? We'll keep on watching. So let's start. Very good if you can draw the things by yourself, right? If you draw it, it will become much easier and much more comfortable. So let's say this was what we were talking about yesterday, right? So this was our that ectoderm, correct? Ectoderm. And then from that notochord was formed, solid structure, notochord, right? And then we were having on its both the sides the somites, right? That was the mesoderm, right? That's the mesoderm. And below we were having, and that was the endoderm, right? Endoderm. Above, things to remember, over here there was one membrane, right, which will be the future mouth. So that was buccopharyngeal buccopharyngeal membrane, right? So that is how we decide that now it is the cranial end. And here is the yolk sac, correct? And over here, this would be the amnion, right, or the amniotic cavity. These are the lateral plate, and yes, this was like that primitive streak, right? So all done, right? This was the beginning. This was the point where we left yesterday, right? So now today, this is our beginning. Now what we are doing is we are taking 2 steps together, right? Yesterday we just talked about that it is this which leads to form. We talked about neural tube also, right? So yesterday we talked about that as it goes down, right, there is involution, and then gradually it remains like this, and the neural tube is formed, right? And the neural tube is formed, right? This was what was called as the involution, right? And the cells which were over here, right, we call them the neural crest, right? So this was neural crest, and this was when it was isolated, right? These cells, they said that yes, we'll be performing our functions by ourselves. That was the neural tube, right? Below was the notochord. Done. Things are not going this much simple, right? Yesterday, deliberately, we skipped one step. And that was the real step is that when this neural tube is getting formed, in fact, the whole thing starts going down, right? So over here, I'm drawing it. It goes like this. Let's change the color so it becomes more clear. These edges, these sides, they don't remain straight. They in fact start going down. They start going down, right? This starts going down. So the formation would be something like this. Remember, this is amnion, right? An amnion is amniotic cavity which is supposed to cover this entire unit. So surrounding the hole, there is a amniotic fluid, and inside there is growth. So here is the process. It goes all the way down, all the way down, and then this is the formation of our neural tube, and this goes down. It goes like this. So this is our amniotic cavity, right? That's the tube. So now I'll not write it, right? You know that this is the tube, and these are the neural crest cells. So things proceed, right? Things they proceed, and this is the mesoderm, right? This mesoderm is also going down, right? This mesoderm, right? This is also going down, and just behind that, you have this notochord, right? Notochord. So what would really happen to the yolk sac? Now yolk sac is changing its shape, right? So previously so it was just like this. Now this is how we were drawing that this and this was the yolk sac. But think of when this side goes down, so yolk sac will start compressing, right? So yolk sac will go something like this, this, right? It will start going like this. That's the yolk sac, right? Still amnion keeps on continuing, coming down and down. So what would really happen is that it will finally cover it fully, right? Meantime, let's just look at this portion, this portion. That is the tube, right? This we did just at the end, just before the completion, we reached to that point. So if I really look at, the right, this was the neural crest, right? This is the neural crest, right? The neural crest, and inside what you are getting, that is the neural tube, because neural tube would be inside, right? And it is divided like this, because what will form neural tube will make brain and the spinal cord. So that is over here. Here the things they start getting divided, right? So there would be forebrain, there would be midbrain, there would be say hindbrain, and then the spinal cord, right? So that's how it would be divided. And on top of it, I'm introducing one new thing, and that is what is called as the optic area, right? So we have got optic area over here. So how we are watching, as if we are just cut the whole thing and we are watching the neural tube from the top, right? Because it is this neural tube, right? It is this neural tube which is like this, right? With a canal, right? What we are doing, we just cut it and we saw it. Till now we were drawing neural tube like this. Very soon we'll be making a small change in its shape, right? Because spinal cord is to be formed. And you know the spinal cord, the way we are drawing every time, it like this, right? Like this. So it should acquire this shape. Right? So we'll come to that. So here it is, the optic area that is there. Then we have got forebrain, right? Forebrain. Then there would be midbrain. Then there would be hindbrain, and then there is spinal cord. Good one. Right? All these things they are developing from the neural tube. So this is prosencephalon, right? Then this one was mesencephalon. then there would be rhombencephalon, rhomben, right? Cephalon, all are cephalon. Spinal cord is spinal cord. So all of them, they are part of it. Neural crest as it is developing. Then what happens? Now, as we move to the next part, take a section in this way. Say, and as we said, the things are developing together, right? So we just draw the neural tube over here, right? Again, still we are drawing the, or let's start drawing the neural tube like this, because neural tube elongates, right? Neural tube elongates. Just behind the neural tube, there would be notochord, correct. Just behind it, there would be introducing a new structure, and that would be the dorsal aorta, right? So when we'll be discussing about embryology of heart, right, that point, at that point, these things will come into picture. But still, because they are happening together, that's why we must know, right? Then, yeah, one more thing which develops, right? The mesonephric duct and the mesonephros for the kidney part, right? So over here, right, there would be mesonephric duct and the mesonephros. Mesonephric duct for the ureters, mesonephros for the kidney, and as it is covering, right? So what we are interested in is that those neural crest cells, right? This is where you have to remember. I'll just write two things and you have to imagine. This is the dorsal part, right? Because dorsal part, that's the posterior part, because and this one is the ventral or the anterior part. Thick, right? Ventral or the anterior part. Because that's where the spinal cord will be developed, so obviously it has to be posterior. Now the movement of the neural crest cell, first movement is dorsolateral, so dorsal and lateral. So this one would be the movement, migration of those neural crest cells, right? This is first migration. So there will be two migrations. Migration one, what is the dorsolateral, dorsal aspect, posterior aspect, and it is going like this. Now immediately you will find that yes, this is where the nerves will be forming, right? Yes, you are 100% right, because this is the crest, right? These are the neural crest cells, and crest is forming the peripheral nervous system. So very right, it will be going over there. Then the second movement would be the ventral movement. This is dorsal, this is ventral, so it should move like this, right? So these are the two migrations. One that is the dorsolateral, and second migration, right? Second migration, that would be the ventral migration of neural crest, right? This will be of great importance as we'll proceed. But just this is what you have to remember. Meantime, because things are moving like this, so there would be formation of even the gut over here, right? Gut. This would be gut, right? We'll talk about this, right? We'll draw a more elaborate diagram. But over here in this diagram, we are just understanding two things: migration of these crest cells, neural crest cells, right? Crest or neural crest cells, dorsolateral and the ventral, right? And this is all, so this is all mesonephros and mesonephric duct, but that's okay, right? Even if you don't remember it right at this point, that's fine. Don't forget that over here, and over here on both the sides, these are somite, right? Somite. All the points, whatever we are talking about, all the terminologies we'll be discussing at length today, right? Till we form the full and final complete brain. Okay. So this is clear, right? Today I'm writing everything individually on separate page, right? As you said in one of the mail. Can you tell again from aortic? Yeah. See this. This is the neural tube, notochord, right? And this one, right? That is dorsal aorta. Dorsal aorta. Because formation of aorta and formation of all the vessels, right? That itself is a huge topic. So right now I'm not going into that detail because we are focusing on nervous system. But you must know, right, that this is the neural tube, right? This is the neural tube. That's the notochord, and the structure which will be coming across then is the dorsal aorta, right? And then over here it is the gut, right? It is the gut. So clear? Remember it from posterior to anterior we are talking about. Fair enough, right? So this is posterior and that's anterior. Now neural tube, right, and the neural crest. This would be playing a vital role. That's why I'm repeating few things again. This is forming CNS. Okay, so all these structures are formed from crest cells, not the dorsal aorta, right? Because crest is forming. So let me write down, right, what crest will form and what mesoderm will form, right? This, it would be very easy to understand. CNS, PNS, central nervous system and the peripheral nervous system. Clear? Central nervous system, the preganglionic fibers, they are part of the brain only. So this is before brain. So this is preganglionic fibers, right? Autonomic fibers. We are talking about that sympathetic ganglion, sympathetic parasympathetic ganglion. So preganglionic fibers, they are from neural tube. Postganglionic, they will be from neural crest, right? Postganglionic. So far it is easy, right? Retina is considered as part of the brain. So we never forget the retina. So retina is part of that brain, right? When it comes to, say, neural crest, things to remember: adrenal medulla, melanocytes, right? Not to forget melanocytes, and this would be very important thing, the facial skeleton and the facial muscles, right? So facial skeletal plus muscles. Let me write it in one different color because it is a vital point. Brain is covered by pia matter, arachnoid matter, and the dura matter. Correct? Brain, right? It is covered by pia matter, arachnoid matter, and the dura matter. This pia matter and arachnoid matter, they are formed by neural crest. Neural crest. The tissue of the brain is formed by the neural tube, but its covering is formed by the neural crest. And the outermost covering, that is the dura, right? The dura, which is for the protection, that is by mesoderm. So this is by mesoderm. Right? Putting a star because you must remember this thing very properly. Neural tube forming the brain tissue is formed. It's covering pia matter, arachnoid matter, that is by the neural crest, and the most outer one, which is for the protection, toughness, durable, dura, that is by mesoderm, right? Very clear. Next, when we were dealing with mesoderm, right, when we were dealing with mesoderm, we talked about that notochord is formed, and then that mesoderm, which is near to that, from the caudal end starts the paraxial, right? Let me write, right? There is paraxial mesoderm, correct? Then that paraxial mesoderm, then on the lateral plate, then there would be from the caudal and lateral plate will extend, and all the way it will extend, right? That is the lateral plate mesoderm. Lateral plate mesoderm, as the name suggests, that it will be going to the lateral aspect and will cover everything. And in between, right, it is the intermediate intermediate mesoderm, all are mesoderm only, right? So paraxial, intermediate, and the lateral mesoderm. What is formed from what, right? See, over here in the central portion there is notochord. Notochord is going to get degenerated. Its function was signaling the neurulation process, so that it was to tell the ectoderm chalo you are neuroectoderm, and then they start forming the neural tube bus, right? After that notochord tells that my function is over, and then it remains as nucleus pulposus in intervertebral disc, right? Surrounding the nucleus pulposus, they are circular fibers. They are called as the annulus fibrosus or the annulus fibers, circular fibers. This paraxial, right? Paraxial is what would be forming the skeletal muscles, right? Skeletal muscles. Then what? Bone, connective tissue, all by them, right? Bone, connective tissue. Yesterday, when we talked about that, what are the structures formed by the mesoderm? So we said skeletal muscle, bone, connective tissue, kidney, ureter, right? All those things, gonads, etc. Now we are differentiating it, that what exactly from what, right? So bone, connective tissues, right? Connective tissues, and we just talked about dura mater, right? Dura mater. So that is formed by the paraxial. Paraxial means it is near to the central axis, right? Near on both the sides. So that's why it is both the sides. What about the intermediate one, right? Intermediate. In intermediate, right? Okay, great, right? So kidneys, right? Then gonads. Then ureter, obviously kidney and ureter, right? And we just mentioned that, right? Kidneys from mesonephros and ureter from mesonephric duct, right? So kidney, ureter, gonads, then the complete uterus, uterine tubes, all those structures, right? So uterus, uterine tubes, that is fallopian tubes, uterine tubes. Then in case of males, vas deferens, right? All those epididymis, everything, right? So epididymis, all those things are formed by intermediate. The lateral, right? The lateral plate, that will be forming two important things. One, GIT, right? GIT, right? Gastrointestinal tract, pleura, peritoneum, and in peritoneum, right, when you'll be studying abdomen, right, in the abdomen, while discussing the abdomen, the entire series of abdomen, when we came to GIT, there is a very important thing, what is called as the rotation. So there is dorsal and the ventral mesentery, and the way they rotate, and that would be the basic foundation of about how to learn the folds of peritoneum. If you learn that rotation, everything will become crystal clear. So that's what has been explained in that video, right? Today we are not touching it, but that's why it is so important. Another thing, lateral plates, very logical, they are going laterally, right? So laterally, so they will be going all the way to the limbs, upper limb, lower limb, right? They will be going all the way to the limbs. So bones, muscles, right? Muscles, connective tissues of limbs, है ना? It makes sense, because as it is going laterally, so then there would be laterally it is going to, then there will be the offshoots for arm, then it will be going below, so there will be formation of legs, and it will take care of everything. Superficial fascia, deep fascia, skin, right? It will take care of that part. Dermis, superficial fascia. There would be one specific mesoderm, and that one would be the cardiogenic mesoderm, which will start appearing. Cardiogenic mesoderm, obviously, that would be for the heart, and its covering is called as the pericardium. So that's why when we talk about the embryology of heart, so we pick up from this point that okay, these are the mesoderm, these are all primordia, and these are the structures which are formed from it, right? Derivatives. So there is formation of cardiogenic mesoderm, and it starts from that point. So here it is. Now we draw it, right? This part, this much portion is, it should be completely clear. Now see, you should know these structures. You know that where exactly the amnion is. Yes, you know that the top portion. Then there are three layers, 1, 2, 3, right? We talked about it. In these three layers, there would be the notochord, right? That would be there. And then we have developed even the neural tube also. Good, right? And then surrounding it, there are the somites. And below is the yolk sac, right? Yolk sac is taking a big portion, right? Right now it is like this. Then this amnion, which is surrounding like this, it starts going down. So it goes like this. This is for the understanding, right? So that's why I'm not drawing all the structures, right? It goes like this. And the yolk sac, bichara, right? He goes like this, right? Compressed. Amnion, one more thing. Surrounding it is what? Surrounding is that chorion, right? Surrounding it is chorion. So one very important statement. Listen carefully. Amnion expands so much so that it merges with, it compresses the chorion completely. Getting it? Say things like this. Say this is the chorion. Currently, situation like this. That's the amnion, the layers, and the yolk sac. This amnion, it expands. Now it goes like this, right? Still more expands. So now it goes like this. It still expands. At one point, it goes like this. Got it? So that's how it has covered everything. So amnion, which was over here like this, now this is the whole amnion, and it has compressed the chorion fully. Meantime, things don't remain just like this. It goes, there is a change in the yolk sac also. Because see, this is a soft structure. It is like a balloon, right? So when it is compressed from both the sides, right? It compresses from both the sides. So even yolk sac will start going like that down, and that would be the formation of the umbilical cord later on, right? And that is where the even the gut would be formed. So yolk sac takes this position, right? Yolk sac, we draw it with yolk sac, it goes something like this. This is the yolk sac, right? This one, which is over here. So now it has taken this position. So it would be like this, this, and this, right? One more important thing, the concept of allantois. The concept of allantois. What allantois is? Till this point, everything is getting formed, right? Everything is getting formed over here. And when the things are taking turn like this, so obviously even this whole thing will also take turn. All these layers, right? All these three germinal layers and all the structures, right? They will also take turn. And we said that this area was the mouth area, right? This one was the caudal area. So even they also develop. So this will lead to formation of three things. One, foregut, midgut, hindgut. Right? Foregut, midgut, and hindgut. There would be at this point of time there would be formation of heart tubes, right? And the stoma, right? Stomedium. That is the mouth. So three things have developed. The mouth, in between this entire thing, in between, right? There would be this. There would be gut, and it is divided into three parts: foregut, midgut, hindgut, and the heart. The heart. In this area, right? Meantime, compression keeps on increasing, right? This compression, it keeps on increasing. So the final effect would be what? It would come in the form of a tube, right? It will come in the form of a tube. We were talking about allantois, right? Let's finish this. Allantois. What exactly allantois is? The allantois is, in one simple word, it is embryonic precursor of umbilical cord, right? That means in embryo, embryonic precursor. Precursor means in future it will become what? Embryonic precursor will become umbilical cord. Embryonic precursor, that is allantois' fate, allantois' future is umbilical cord. Umbilical cord. So with perspective of umbilical cord को if you पूछो कि पहले आप क्या थे, तो he'll say कि पहले I was allantois. So what allantois is? Allantois is nothing but a small protrusion in the yolk sac, right? In the yolk sac. So if I really want to add that part, I could draw it something like this. Like, I'll use the green color only. It would be a small protrusion like this. So here, that small protrusion, which is, okay, this is our amniotic cavity. This small protrusion, this allantois, right? Again, it would be squeezed all the way, right? And finally, the final effect would be something like this. The whole thing, right? This, right? And then over here, in between the squeezed yolk sac, that allantois, right? They are all squeezed. So yolk sac, right? This would be like previously the yolk sac was round, bulging. When we have compressed, so it is like a stalk. It is like a line, thin line. So now we start calling this as what? Yolk sac stalk. Stalk means like a parallel thick line, right? And this is allantois, right, which was just a small protrusion, but now it has become part of it. So this is plus allantois, right? Allantois. Both of them, they are forming what? They are within the umbilical cord, because this would be the formation of umbilical cord, right? Umbilical cord. When this thing happens, surrounding, to we know that there is all amnion, right? The importance of allantois is that it will lead to formation of two important things. This would be the umbilical vessels and urinary bladder, right? Umbilical vessels and urinary bladder. So that's the beauty of that small protrusion, right, which has come up, and now it is passing into it. But yes, this will be helping into formation of this. So situation is like this. One, the yolk sac stalk and the allantois, they are there, and then surrounding is all amnion, right? Amnion surrounds this umbilical cord also, right? So this is, it surrounds, and this amnion has pressed completely, the chorion, right? So because this will be the outline, amnion expanded. So here amnion pressed against chorion, right? So these are the points. First point, second point. And what about this in between things? So many things have developed now, right? So many things. So we just, it has started taking this shape also, right? So that is where our all the structures are lying. Our neural tube would be lying posteriorly, right? So that is the neural tube would be lying over there, right? The gut which is developing, that is in front, right? Makes sense. Then this would be the anterior area. So this is where the heart would be formed, right? The heart would be over here. Gut would be over here. Neural tube is over there because later on it will be leading to formation of spinal cord, right? The stoma, mouth part is over here. The caudal end is over here. So that's where the gut would end. And this is where the gut would start, right? So that's how we divide it into various parts. And the heart is in front. See, this is the most primitive structure, the primitive diagram, which is representing that what is happening exactly, right? Things still continue. Things still continue, and later on, this gut will start taking the complete shape. So that is this is how it will look like. That now we are drawing our neural tube like this, right? Not only that, we are drawing its internal canal something like this. These are the cells. These are the cells, right? So that means there is some formation of ridge. Yes, that ridge is very vital, very vital. Then that's the notochord, right? Which will keep on, which will be continuing as a nucleus pulposus at a final stage. And then surrounding on both the sides, there would be what? There would be somites. There would be somites, right? The gut will be formed, right? That would be the form because the whole thing has compressed it so much, and this is the yolk sac stalk, right, which is compressed into the umbilical cord, right? And let's cover this entire portion in like this. So fully covered, right? And like this, right? And this is our amniotic cavity, right? Done to this. Now we have got two important structures which are to be taken into consideration. This gut, right, as things keep on moving, this will start moving up. So just wanted to add the concept of dorsal mesentery and the ventral mesentery, right? So this gut tube, right, it moves and it forms, right, over here. It's like this. It forms the mesentery, right? This is the gut tube. That's the gut tube. So where are rest of the structures? Well, that is after the mesentery. After the mesentery, right? So there would be aorta over here, right? And after aorta, there would be all those, say, that's the neural tube and dermatomes and all those structures. But this and this is the posterior portion. So this is dorsal and this one is ventral. So that is ventral. They are called as the mesentery. Mesentery. Because this gut tube then will start rotating, and when it will rotate, yeah, dorsal aorta, when it will rotate, right, when it will rotate, so that will lead to formation of the entire GIT in its all of its shape, right? And then where is that umbilical cord? Well, that umbilical cord is after this. This is the covering. This is the covering, and then comes the umbilical cord, right? So this is whole formation, and that's the umbilical cord. Wanted to emphasize on only one thing, that it is the gut tube, right? It is the gut tube which gets isolated so that there is mesentery, dorsal mesentery and the ventral mesentery, right? There is one layer in front, one layer is in back, and this will be the future peritoneum, and when they will rotate and they will form all the layers, right? Okay. So neural tube, we are step by step adding few structures to that, right? So we know that CNS, it forms the CNS. So forms what? Brain and spinal cord. Good. But it also forms supporting cells. Supporting cells. And in histology, we have talked about it, right? So here, oligodendrocytes, astrocytes, etc. They are all formed by the neural tube, right? Cranial nuclei. Cranial nuclei. You won't have to cram that which nuclei is mixed, which is sensory, which is motor. Everything would be crystal clear the moment you see the embryology, right? So we'll see that. Presynaptic, this we have already talked about. Presynaptic autonomic neurons, right? Autonomic neurons. So that is also by the neural tube. One more thing. This is, say, in spinal cord. In spinal cord, we know that this part is dorsal, right? That is sensory, right? There is dorsal root ganglia, and then this is motor, right? That is ventral root. And this is the somatomotor neuron, right? So somatomotor neurons, that is also by of PNS, that is also by a neural tube, right? So we have added two things into this. One, the cranial nuclei, supporting cells, and the somatomotor neurons of PNS. Because see, it is not only that spinal cord is to be formed, but even the complete structure in the form of, right, just again, spinal cord, right? In spinal cord, there is dorsal root ganglia, right, which goes for the dorsal root, right? And then there is ventral root, right? This ventral root, as it comes, they both of them, they combine, right, to form what is called as the spinal nerve, right? This is the spinal nerve. This spinal nerve will again, so this much portion is inside the vertebral column, then spinal nerve, and then it divides into dorsal division and the ventral division. Dorsal division, which will go towards the back muscles and the those cutaneous supply. Ventral will go towards the anterior portion, and then in between there would be sympathetic ganglia, right? Sympathetic ganglia. So there would be white rami communicans and the gray rami communicans, right? And all these sympathetic ganglia, they are interconnected with each other. So the point is that when we say that it is the spinal nerve is carrying all the fibers, right? All the fibers. Amongst those fibers, there would be the fibers which are for sensory. So those sensory fibers, they will be taking this path, right, via dorsal root ganglia, and they will land into this. There would be motor fibers, right? There will be motor fibers. So those are the motor fibers which will be coming out of it, and then they will be going into the same conduit, same pipe as that of spinal nerve, and then those fibers, when they go out, few of the fibers which will be supplying to the back, right, they will go to the dorsal area, and then these is the ventral area. So there is a dorsal division, right? This is what is called as the dorsal division, and the ventral division of the spinal nerve, and these are the dorsal root and the ventral root of the spinal cord, right? Crystal clear in this, right? This portion, this one, beyond this is all inside, and this is outside, right? Outside, because all those spinal ganglia, they are outside the spinal cord, right? And this is inside. For the neural crest, right? For the neural crest, amongst all those things are like PNS, right? Sensory neurons in PNS, postsynaptic, right? So peripheral nervous system, that is formed, that postsynaptic, that is, but the way they were supporting cells, so over here that would be the Schwann cells. Do remember Schwann cells, right? They are by that. Then adrenal medulla, right? We talked about then melanocytes, right? Melanocytes, and most vital to remember, arachnoid and pia, right? This is what we said, that these are the arachnoid and pia matter by the neural crest. What was by who was responsible for formation of dura matter? Well, that was by paraxial mesoderm. Good. So that is done, and all the way now we have reached to this point where we are zooming and the focusing only on neural tube, and we are now changing the shape of the neural tube. As said, that this would be now shape of the neural tube, right? These are all cells. These are all cells. So that's a new. This one central is the central canal. This ridge, right? This ridge, because inside, if you really look at in 3D, right? If you really draw it like this, right? If this is the tube, right? So this ridge will go like this, right? Internally, it is the ridge all the way. So that's why when it is a ridge, so we call it sulcus. Sulcus. This is called as sulcus limitans. Sulcus limitans. This sulcus will be all the way from one end of the neural tube to the second end of the neural tube, all the way, right? And on top of it, right, there would be a cover, right? This cover, right? That is what? That is the, not as per the proportion, right? This is the neural crest, right? All those neural crest cells. And on top of it, we have that ectoderm. That ectoderm. Okay? And surrounding it over here, this is all the mesoderm, and that mesoderm, right, into those three parts, and below is the endoderm. Now focusing on sulcus limitans, what we'll do is first we'll draw our normal this is central canal, right? Spinal cord looks, mature spinal cord looks something like this. To remind you, in case of brain, we said that, do remember it like this, the inner part of the brain, right? It is all straight lines. It is called as white matter. It was having axons. It is also called as medulla, correct? Outer part, oh, circular lines. It is gray matter, right? Which is having body, and it is also called as the cortex. Done. In case of spine, things are reverse, right? Things are reverse. So when we say spine, so in spine what happens, that inner part is gray. So in spine, this inner is gray matter, and the outer one, that is white matter. Let's highlight it like this. So that's, we have made a color change, right? So this inner would be the gray matter. This one is gray. In gray matter, there are three columns. One, ventral, dorsal, and then there is lateral. So these are also called as the horns. So dorsal horn, ventral horn, and the lateral horn, or the lateral column, right? These are also called as the columns because basically they are columns. White matter is outside, right? So this one is white matter. This white matter is doing what? This white matter would be carrying the tracts, all the tracts, right? So if I divide it into two parts like this, if I divide it into two parts, right? So one is posterior, one is anterior, right? So this one is posterior or the dorsal, and this one is anterior, right? This one is anterior or the ventral. So obviously that something which is in anterior, ventral, so it will be carrying the tracks, right? It will be carrying the tracks for motor, right? Because this is the motor part, anterior is the motor part, and posterior is the sensory part. Sensory part. Because finally, this thing is formed in what way? It is the game of body and the axons, right? So these are the tracks which will be going up. So here we'll be getting all the tracks, all tracks, right? Here also there would be tracks, right? There'll be all those columns, right? They'll be like big columns which will be going from all the way top to bottom, right? Various columns, track of Gall and Burdock and all sorts of, their names will indicate where they will be landing. But the whole idea is very clear that it is the white matter, right, which is outside, and that would be the track, right? It is outside, different than brain, right? So do remember the brain, and this becomes easy. Okay, but this is the mature spinal cord. When we have got the neural tube, right, things are not like that. So in that case, say something around about 35-36 days, right? 35-36 days. So imagine just within 1 month, so much has happened. A neural tube will now acquire the shape something like this, right? This is like a morphing, as if one structure is getting morphed into another structure, right? So that is like a morphing. Finally, it has to acquire the shape of the spinal cord. This would be the sulcus limitans and the central canal. This sulcus limitans is what is dividing it into two parts, and that's what is called as the dorsal alar and the ventral basal, right? In simple words, the dorsal part and the ventral part. Ventral, dorsal and ventral. This dorsal is also called as the alar. So dorsal alar and ventral, right? It is like a base. This is like an apex, right? So this is base. So ventral basal. Right? So not very complicated. Just this is called as the dorsal alar plate and the ventral alar plate. Dorsal, that would be sensory. Makes sense, right? That it would be sensory, and this ventral, that would be motor. Now things are easy. Yes, exactly same way it will literally transform itself into that top shape, right? The shape which is on the top. So for that it has to be divided, right? It has to be divided. So now it gets divided like this. Say there is formation of, they will change the shape. This is called as the mental layer, right? It is called as the mental layer. Things which are outside that mental layer, outside, it is called as the marginal layer. Marginal layer. So we have got the mental layer and the marginal layer. And then you should not miss, there is one layer which is over here. It is ependymal layer, right, which is next to the spinal cord. So that is ependymal layer. All you need to imagine is this. what we drew over here, this green portion, right? What we drew over there. So that mental layer will form this green portion, this, right? So we just draw it like, the paint it like this. The rest is all just the modification of the shapes. Obviously, there will be formation of those cranial nuclei, there will be formation of the rest of the nerves. But from the perspective of spinal cord, what is happening is this. It is this green portion which will later on form all the horns, right? All the horns. Now, see this image and think it like, what if it modifies and say this central canal will go down, right? This will go down. It will become just small central canal, right? Finally, it will become that small. So that is because this mental layer is expanding and taking the shape. So here it is, this figure, and watch this. The central canal has become so small, right? Ependymal layer. And this mental layer, it has formed this entire shape, making all the horns. Right? Clear? Right. And this marginal layer, if you want to put it like this, right? Just put it like this marginal layer. So that's the marginal layer. That marginal layer has become this. Right. So we'll just write like from marginal layer, right? And lateral, that is from mental layer. And yes, this would be the white matter. The outside would be the white matter, right? And this one would be the gray matter. So that way, when the spine starts getting developed, right? So this spinal cord, when the baby is about say 2-3 months, right? Just 2-3 months. So at that point, relationship in fetus is almost similar, right? All same, right? S1 is at S1, S2 is at S2, everything is same, right? So all levels are same. But then at birth, right? At birth, it changes. Now S1, right? The root of S1 will actually originate at L1, right? So S1, the sacrum, right? Sacrum 1, that will come up, right? So it will originate at L1, right? Spinal cord, it will end at, right? Spinal cord ends at the level of S3 or L3. L3. At the level of L3 vertebral body, it ends, right? So that's what really happens at birth. So gradually, as the body expands, becomes big, right? So it goes more and more below. Finally, this say in adult, it goes even still higher because spinal cord at birth it is still the level of L3, but in adult spinal cord ends at L1. It ends at L1. Now, if we watch from the side, now this fetus has started taking a shape, right? It takes a shape, and on the both the sides, all these mesoderms, right? They will start forming the myotomes, right? They'll start forming the myotomes. So these are, there will be the occipital myotome, then cervical, thoracic, lumbar, sacral, right? The distribution same way, right? So right from the top, say there would be the occipital myotome, then there would be cervical then there would be thoracic, right? So that way it will go all the way till lumbar, sacral, and coccygeal. These are myotomes. So now it is forming that shape. We talked about the nerves, right? We talked about the neural tube. Now we are drawing only the neural tube, right? Only the neural tube. So this is the neural tube. Initially we said that, okay, if we look from the side, that neural tube is slightly expanded at the cranial end and then it goes like this. ठीक? Change it. We add two curves, or they are called as the flexure. So one, we create the head because that from there we'll be creating the brain. So let's say this, and it flexes, bends. So this is the first flexion, right? Then there would be something, and then there would be another turn, and then it will go down. These two flexures, the tube which was just like this, but now from one point it is bending more. So this is called as the cephalic flexure. Cephalic flexure, right? And the second point where it is bending, it is called as the cervical flexure. These are the two areas. These flexures will actually decide that this portion is now called as the forebrain. This one is the forebrain between cephalic flexure and the cervical flexure, right? Just behind the cephalic flexure, right? We have this portion. This is the midbrain. And then all the way to the lower till this point, this is the hindbrain. So between these two flexures, we have got the midbrain and the hindbrain, and after this cervical flexure, all the way, it is the spinal cord. Now, forebrain is also called as the prosencephalic. This is called as the mesencephalic, right? And this hindbrain is called as the rhombencephalic. We'll be dividing it into further divisions, right? Because we really want that where exactly those cranial nuclei will develop, right? From which part, etc. But first, exactly the same shape, we just take a section. We take a section as if just a blade which has taken off the one layer, the cut out of it. So it's like we'll be watching the internal structure of it. So let me copy this thing, right? Duplicate, and so same image, but now we'll be watching inside of it. So first thing which we see inside is something like this. What is this? Sulcus limitans. Now you got it, right? In other words, we are watching it. Now we have put the cut over here. So this part is removed, and we are watching that's the sulcus limitans. So this is sulcus limitans. To this, we can also watch one other important structure, and that is the optic vesicle. So it is the optic vesicle. There is opening. Forebrain, yes, that is the forebrain. In forebrain, it is this area. There would be one more sulcus. And that one would be for the hypothalamus. Right? So we'll very rightly said hypothalamic sulcus. Right? Over here, we were watching the things from outside. So we were watching only the major curves and everything. But over here, after cutting it, we are going inside and we see that, okay, hypothalamic sulcus is over there. That means hypothalamic sulcus is part of the forebrain, right? That is how it will be forming. Rest all are all good, right? Rest is all good. And if we take another section, right? This was a sort of like sagittal section. Sagittal section. If we take that, that's a brain, and we take section, frontal section. So how the same thing would look like? Well, in that case, on both the sides, right? We are, let's draw it a bit smaller one, right? Like this, yes, like this. There will be the optic vesicle, right? Then there would be midbrain, then there would be hindbrain, right? And uh, this is at how many months? Uh, this would be, say, in fact, the whole brain will be almost ready by say 3 months, right? Even before 3 months. This is something about 35 days, right? Even before 35 days. Achha. Just a minute. I finish it, and then I'll tell you the steps also. So this was what? Optic, right? And the forebrain, then there is midbrain and the hindbrain. And from there, it will go down in the form of the spinal cord, right? Spinal cord. So we have forebrain, forebrain, we have got midbrain, and we have got hindbrain, right? Midbrain and the hindbrain. Clear? So this is what we are watching in the form of a frontal section. Going back to the same image, this one, right? This one. So as things grow, right, I'll tell you again few more terminologies which you must remember. Now, before we start with that, right, these are the cranial nerves, right? Cranial nerves. Because now we'll be watching that these cranial nerves, they'll be emerging from which section of the brain, right? Now, cranial nerves, they can be divided into motor and sensory, and third one is the mixed one, right? So we'll come to that. Start with, right? Very easy. Olfactory, smell. So this is one. Sensory. Optic, right? That is this. Then, so they will be from the forebrain. Third one, oculomotor, for the eye. 3, 4, and 6, right? These are all for the his oculomotor, trochlear, and the abducens, right? These are for the ocular muscles. These are for the ocular muscles, right? The lateral rectus, superior oblique, and rest by number 3, right? So these are the muscles. So this is mixed one, right? All the major ones, they are mixed one. So this 5, this number 5, trigeminal, tri, that means it is 3. So we literally put it like this, right? So it is the mandibular division, maxillary division, frontal division. So trigeminal, 5. Facial, very important, right? Big one. So it is a mixed one, correct? Then eighth is vestibulocochlear, ear. So again, it has to be sensory, right? So vestibulocochlear. Ninth one, right? Ninth is glossopharyngeal, right? Glossopharyngeal, pharyngeal. 10th, no doubt about it, right? Vagus, it has to be mixed. 11th, well, it is accessory for, right, back muscles, for the back muscles. And finally, the 12th one is hypoglossal, right? And hypoglossal is for tongue. Right. Done. So very clear that which one is motor, which one is sensory. Right. Now what we do is we see from where do they come. So for that, we'll be drawing one image, but before we draw that image, we'll write something. So it will make our concepts clear. Forebrain, right? You are about to complete the entire brain. Forebrain is divided into two parts, right? Neural tube dividing into forebrain, midbrain, hindbrain, and the spinal cord. But right now we are not talking about spinal cord, right? This forebrain will be divided into two parts, telencephalon and diencephalon, right? So this is telencephalon and the diencephalon. So telencephalon will do what? Will parallelly keep on writing even the nerves, right? That is from where the nerves will emerge. You know, we talked about that olfactory and the optic. Olfactory and optic, they are what? Sensory, right? They are sensory. Telencephalon 1, diencephalon 2. These are the cranial nerves, right? So this is olfactory from telencephalon, diencephalon is from the optic. So if we say this is optic diencephalon, right? We'll talk about telencephalon. So optic, this would be all the optic cup, right? Then thalamus, hypothalamus, right? They will be part of it. What about telencephalon? Telencephalon is cerebral hemisphere. So we draw one image. So zooming on it like this, say telencephalon and diencephalon. So just think it like this is our forebrain. Okay? This is our forebrain. Erasing it, drawing it again. This is the forebrain, right? Drawing it again. This is the forebrain, right? Still this is a forebrain. Drawing it again. This is the forebrain. We are just drawing the forebrain only. Forebrain, right? And what it is, this one, the outer one, right? That is telencephalon, right? And this inner one is the diencephalon. Both were part of the forebrain only. Over here, both are part of the forebrain. So this telencephalon, right, gradually, what it is doing, it is taking over the diencephalon. So telencephalon will be forming what? Yes, you are right. That is cerebral hemisphere. That's what I wanted to emphasize on. Cerebral hemisphere. It will be forming so many other structures, but this one is vital. And this is one. So obviously this is olfactory cortex. Olfactory cortex. If you remember, these two things is more than enough. Otherwise, many of the other things are like, say, basal ganglia, it is formed, hippocampus, right? But we'll talk about those things when we'll actually learn about those structures. Otherwise, it will become like a fantasy. कि हाँ ठीक है चलो दो extra नाम बोल दिए, right? Surely I would like to add, because you know that cerebral hemisphere, they are on both the sides, and inside the cerebral hemisphere there is what? Those ventricles, right? Lateral ventricle. So lateral ventricles, right? Are you with me? Lateral ventricles, right? Because cerebral hemispheres, they are on both the sides, and inside there are lateral ventricles. So there is one lateral ventricle, there is second lateral ventricle. Both of them, they combine to that interventricular foramen, right? Interventricular foramen, which opens into third ventricle, correct? And then third ventricle to fourth ventricle, and that fourth ventricle will open into subarachnoid space. Foramen of Megendie and foramen of Lashka. Lashka, they are on the lateral side. Megendie, it is medial. And this top interventricular foramen, that was called as the foramen of Monro. In between, there is cerebral aqueduct of Sylvius. right? So this lateral ventricle, it is into cerebral hemisphere, so that's why it was easy for us to figure out. Okay, yes, very true. Olfactory is the first one, right? When we'll see the dissection, immediately those olfactory bulb, they are the anterior most, just in the base of that frontal lobe, right? So that is telencephalon. This is a big one, and it will be covering this diencephalon. So diencephalon, that is the optic cup, and the thalamus and the hypothalamus. Now you know that thalamus, hypothalamus, when we'll be watching the real brain, right? So thalamus, hypothalamus, they are in the center, and it is covered by a helmet of cerebral hemisphere. They both are part of the forebrain only, right? And telencephalon, this is olfactory. Diencephalon, that is optic, right? These are cranial nerves, right? These are the cranial nerves. I'm just writing CR, right? Cranial nerves. Now, when the brain is getting formed, it is not like that with the knife exactly the cut is put, chalo, this part is telencephalon, this part is diencephalon. So that's why the part of the third ventricle, that is also formed by, so here say telencephalon, right? This is the third ventricle, also it is formed. So lateral ventricle and third ventricle over here, part of third ventricle. This then would be crystal clear when we'll be discussing the CSS circulation. So where we'll actually draw each and every part, and that part also will say the third, lateral third, that is by talon, and this lower portion of the third ventricle, that is by diencephalon. So far, so good, right? All clear. We take a fresh page, in the new page. Okay, let it remain as it is. To this, we add, now we talk about midbrain, right? Midbrain. Exactly the same way, the way we learnt the forebrain. Midbrain is called as what? Mesencephalon. Mesencephalon. So that is like a small dia, that it is not, there is not much of the further divisions, right? So it is leading to formation of all the substances, like, say these are the names, but cerebral aqueduct, you know, cerebral aqueduct of Sylvius, aqueduct, that is which is formed. Then some very crucial substances like red nucleus, substantia nigra. But at this point, just remember it like the name. And even if you forget, that is not a problem, because we have not really touched these areas. But by the time when we'll finish the brain, all these areas will be crystal clear. Cranial nuclei, we are interested. Cranial nuclei, midbrain, cranial nuclei. That would be third and fourth, right? So third and fourth. Third, oculomotor, and this one is trochlear, right? Trochlear, which is supplying superior oblique, lateral rectus is by number 6, and all rest of the muscles, right, they are by oculomotor. This is pretty simple. Writing something in the square. Crus cerebri. We'll not say much about this at this point of time, but yes, this would be an important structure, right? We'll see that when we'll be discussing brain. But see, basically midbrain is forming all those structures which are somewhere in the middle, right? Somewhere in the middle. So we have got one big processor unit in the form of forebrain, where there are basal ganglia, right? Then there was olfactory cerebral cortex, that is cerebral hemisphere. Then underneath there were thalamus, hypothalamus, which are handling those important functions. Midbrain is red nucleus, substantia nigra, right? These two. The interesting part is the hindbrain. Hindbrain. Like forebrain, this will also be divided into several parts. Two. One, what is called as the metencephalon, and second would be myelencephalon, right? Metencephalon and myelencephalon. This is forming two pons, and behind it is the cerebellum. And myelencephalon, it is the last portion. No wonder it would be for medulla oblongata, right? And all the nerves, wrist, all the nerves, they will be, that is 5, 6, 7, 8, 9, 10, 11, all the way, they will be from this, right? So 5, 6, 7, 8, 9, 10, 11. 12 will be at the still, sorry, this I should make 12 because accessory has got a very special pathway, right? Accessory has got a different pathway. So these are the nerves. Remember, 11, I'm cutting it. Okay? So this is how it is formed. Now let's draw it, and immediately you'll find that yes, things are easy, because then it would be just one state. The telencephalon will start enlarging it, right? And as it enlarges, it will start covering all those parts, the parts of diencephalon. Right? As far as possible, we'll try to change different colors. So this one would be the the telencephalon. Telencephalon, so this would lead to formation of cerebral hemisphere, right? So we write T, telencephalon. It would be covering what? It would be covering the diencephalon, right? So this is the outline of the diencephalon. So that's how it would be covered. From this, there would be formation of this very cute, that is the pituitary, right? So that is the hypophysis. And from this, what's that? Optic, right? So in that case, olfactory, it has to be anterior to it. Yes, it is anterior. So this would be the olfactory. This would be the optic. This is the pituitary, right? And this is the diencephalon, right? Moving further, right? Moving further, there will be the flexure, right? That will be the flexure, and then there is a mesencephalon, right? That's the mesencephalon. So mesencephalon, this is mesencephalon. Then from mesencephalon, it will move to formation of the metencephalon, because this is what? This is forebrain, right? This one is forebrain. This mesencephalon, so this is midbrain, right? This is mesencephalon. So now we are left out with the hindbrain. Hindbrain is divided into two parts, metencephalon. So that's your like this, right? Because cerebellum, chota dimag, right? That is in the back. In the front, we have got the pons, right? So this portion, this is called as the metencephalon. Metencephalon. And after that, this is like this is like this, and it goes down. So this is medulla oblongata, right? And that is myelencephalon. Collectively, it is the hindbrain. And then it continues as the spinal cord, right? Very fine. In the spinal cord, there are few enlargements, right? Say, for example, there would be cervical enlargement. So spinal cord is not like absolutely like a pipe, right? The spinal cord, it would go like this, that there would be expansion at the cervical, then there would be, as it will go down, then there would be another expansion at lumbosacral, right? So these are some expansions. So lumbosacral and the cervical. These are enlargements, right? So enlargement or the enlargement. So this is how the brain is getting formed. Then it is a matter of just it keeps on expanding, right? To achieve this state in which there is huge cerebral cortex, right, which takes over like this, right? Then there is olfactory bulb, which is over here, right? And then say rest of the areas, right, which is in the form of say temporal lobe. So there would be the frontal lobe, right? There would be frontal lobe, there would be occipital lobe, and then below there would be the temporal lobe, and over here it would be the parietal lobe, right? These are the lobes. So these lobes, they will be covering the diencephalon, which is inside. Meantime, this posterior portion, this one, that one is, it leads to the formation of cerebellum, right? Cerebellum. Cerebellum was what? Cerebellum was our part of metencephalon, right? Cerebellum and pons. So cerebellum is here, the pons has to be here. Pons has to be here, right? Then still further over here, there is something which you have to draw like this, like this. This is very crucial. This, if you say it is medulla oblongata, we have got over here pyramidal tracts. Pyramidal tracts. Right? So that is the pyramid. Right? This one is the pyramid. So bulge. And this one would be the spinal cord. Spinal cord. Right? So we have got occipital four lobes, and this one would be the basic brain. This is very interesting area. It is called as the insula. Right? It is very interesting area. As the brain goes into its full-fledged final maturity, the brain would look like this. No, again. Right? And like this. To the depth, right? Brain is thrown into folds. Brain is thrown into folds. Like this. So this is called as the sulcus, and this prominence, it is called as the gyrus. So we have got sulci and gyri, right? Singular and plural. Sulcus singular, sulci, similarly gyrus, gyri, right? Gyrus is prominence. This is cerebellum. This is called as the central sulcus. Central sulcus. If you want to learn brain, learn it in this order, become very easy. Central sulcus, right? It is also called as a Rolandic sulcus, not circus, Rolandic sulcus. This is anterior, right? This is posterior. So this is frontal lobe, right? That is frontal lobe. Central sulcus or Rolandic sulcus, right? This is motor, and just behind it, it is sensory. See how easy it is, right? Then this area, this is your temporal lobe, right? So over here, this is the lateral sulcus. Lateral sulcus. Lateral sulcus is important because at the base, in the floor of lateral sulcus, there is one area, this area, this area. It is what is called as the insula. Insula. This insula is for expressions, right? Insula is for that empathy. Insula is for happiness. Insula is for, say, sad, guilt, and then anger, fear, anxiety, right? All those emotions. That is for this insula, right? Very important area. Plus, it also carries that gustatory means taste, gustatory, gustatory sensations. So the taste sensations, they are handled by it, right? Your risk reward, right? This risk reward behavior is what? If we do something good and if no one appreciates, we feel like forget nahi karna, right? Even if you are doing good. Risk is when you judge that whether I should take a risk and then you try to do it. Pain pathways, pain pathways, very important. Right? It processes auditory and vestibular, right? The balance functions, so listening and balance function, vestibular functions. That is all handled by functions. That is all handled by this insula. And finally, what is called as the awareness, right? Even if you close your eyes, but you feel like that, okay, what is to my right, what is to my left, right? The awareness of surrounding and the awareness of your body, that is by insula. Insula is one of the very vital area of the brain which is for neuro linguistic programming. That is when you want to develop, it is like talking to yourself, how you can really take off your all hidden fears, how can you really improve the efficiency of your brain. The thing what is called is the neuro linguistic programming, the language with which you are talking to your brain, and you are conditioning your brain in such a way that you are sitting silently, but the moment the exam comes, right, when you are appearing for the exam, when you are appearing for any of the interviews, suddenly one tap, right, it could be just anything. There are multiple signals which can be generated by various gestures, but that signal is generated because it is specifically for you, and your brain goes into that super mode, right, as if it is like a turbo into those car racing games, and your performance would be absolutely amazing. So that's why this area, that is very, very vital, right? Insula. Rest is all easy, right? This is like central sulcus. Then after then there would be pre-central sulcus, and then there would be post-central sulcus, right? Similarly, there would be pre-central. So here is the sulcus. So in between, this one would be called as the gyrus, right? So this would be pre-central gyrus, and this one would be the post-central gyrus, right? So over here there will be another sulci. So many sulci, right? One another, say this area is what? This is occipital, right? This one is occipital. This above one is parietal. So there would be one more which will be passing in between. So that is called as the parieto-occipital, right? So this one would be parieto-occipital sulcus. So these are some of the main sulci, but the idea is this, right? That's how, say, things they develop. And when we add something more to this, so this would be where the pons will be there. On the back side, there would be like cerebellum, and then we have got, right? This is the pyramid, and then there is this medulla oblongata, and then it goes all the way into the form of spinal cord, right? Things would continue. So from Monday, what we'll be doing is we'll be actually start discussing every area of the brain individually. So at that point, we'll be talking about that this is how it was developed. This is the part of forebrain. This is the part of midbrain. This is the part of hindbrain, right? Metencephalon, myelencephalon, and what functions is it carrying? Where exactly will it supply? What it will be handling? So everything would be under that light, right? So this is how the brain actually forms. Right? Thank you so much, and see you on Monday with another topic. Right? Thanks a lot. Revision, chalo, let's do it. So, neural tube, neural crest, lateral plates, notochord, right? And presynaptic plus CNS, that is by neural tube, postsynaptic and PNS by the neural crest, right? Buccopharyngeal membrane, that is what will be the future mouth. Amnion, that's the amnion, this is the yolk sac, and we have got ectoderm, lateral plates, endoderm, that one is the notochord. And the whole idea was that it is the amnion which starts covering, right? And the yolk sac is getting compressed in between the neural tube which is formed, and that one is the notochord. Then we saw that what really happens into the neural tube, it gets divided into parts: forebrain, midbrain, hindbrain, the spinal cord. Prosencephalon, mesencephalon, rhombencephalon, these are the names. And then we have got the crest which is surrounding it. And then there is optic area, right? So here it is to show that the migration of neural crest cells from the goes into the dorsolateral aspect and goes into the ventral aspect. That is where it will be forming various structures. Right? Neural tube, CNS preganglionic, and the retina, neural crest, PNS, postganglionic fibers, adrenal medulla, melanocytes, and the facial, skeletal plus muscles. Talking about this again and again so that you remember that it is from neural crest, because formation of entire face with all the phalangeal arches, that is a beautiful topic. Point to remember, the three meninges. So dura mater, that is by mesoderm, right? Pia mater and arachnoid mater, they are by neural crest. So here it is mesoderm, paraxial, intermediate, and the lateral plates, or the lateral mesoderm. Paraxial, skeletal muscles, bone connective tissue in dura mater of the body, right? For the arms that and the lower limb, it would be the lateral plate, because from the lateral side it goes, right? Intermediate, the major organs, which are kidneys, gonads, ureter, uterus, uterine tube, and vas deferens, and the epididymis. GIT from the lateral plate. Cardiogenic mesoderm, right? That is over here, right? Cardiogenic mesoderm, and that leads to formation of heart and pericardium. Now, amnion has started increasing in size, surrounds everything, and we have got a terminology to be discussed, allantois. Allantois is nothing but a extrusion, a pouch, right, which extends. Basically, it is the embryonic precursor of umbilical cord. So we have got mouth, gut, and the heart, and this gut is foregut, midgut, and the hindgut. So it divides. Here it is. Right? So we have got the gut, neural tube, cardiogenic, and amnion has compressed the chorion, and allantois, which will go later on to the formation of umbilical vessels and the urinary bladder. Right? So that's the whole area, and it keeps on continuing. Dorsal mesentery and ventral mesentery, that was the intention to explain that it is the gut which is like hanging in between, and then when it rotates, so obviously the membranes will also start rotating it. Neural tube, CNS supporting cells, oligodendroastrocytes, right? Cranial nuclei, presynaptic autonomic neurons, and the somatomotor neurons. Now this part too is very clear. Spinal cord, we have got dorsal root, ventral root, right? There is dorsal root ganglia, and both of them, they will combine to form the spinal nerve, and spinal nerve will come out through the vertebral foramen, and then it will divide into dorsal division and the ventral division, and it continues. Right, here is the neural crest. Peripheral nervous system, postsynaptic fibers, Schwann cells, Schwann cell which will be forming one-to-one myelination of neurons, adrenal medulla, right? And then this is like melanocytes, arachnoid and pyometer. Yes, that is by the neural crest. Well, again, the dura mater is by paraxial mesoderm. That's the situation. We have got the ectoderm, we have got the neural crest, we have got the neural tube, and in neural tube we are adding this new concept, and that is the sulcus limitans, right? It is the sulcus limitans on both the sides, right, which will be going inside. We'll divide the brain into two parts. So here it is. First we see this. That's the sulcus limitans, right? That's the sulcus limitans, right? So we have got the dorsal part, dorsal alar plate, and the ventral part, ventral basal plate. It is motor, ventral is motor, dorsal is sensory, right? In this, we have now mental and the marginal layer. This mental layer, which is surrounding the central canal will become smaller, right? And this mental layer will lead to the formation of gray matter. And in this gray matter, there will be the horns, the dorsal horn, lateral horn, and the ventral horn. So these are the horns, and that's how it would form. This is completely in reverse as compared to brain. In brain, it is the inner part, which is white axon and it's called as medulla, and it is the outer part, which is gray body and the cortex. In spine, inner is gray, outer is white due to the tracks. So here it is, mental layer and the marginal layers. Spinal cord at birth, say when it is 2 to 3 months, so all levels are same, right? But then the spinal cord is not growing at that pace, the pace at which the vertebral column grows. So at birth, S1 is at the level of L1. S1 originates at L1, so above. Sacrum 1, right? Spinal cord ends at L3, but in case of adult, spinal cord ends at L1 only. So thus, all those lateral mesoderms, they will start creating those myoderms at every level. So because that mesoderm, that middle one, right, it has spread across all the entire body, right? So there is occipital, cervical, thoracic, lumbar, sacral, coccygeal myotomes. Here it is, the forebrain, midbrain, hindbrain, forebrain prosencephalon, mesencephalon, and rhombencephalon. There are two flexures, that is two turns, right? Cephalic flexure and the cervical flexure. For the further divisions, right, it is where we see that hypothalamic sulcus and forebrain, and that one is optic. Here we discussed about cranial nuclei, motor, sensory, and mixed, right? 3, 4, 6, 11, 12, they are motor, 1 to 8 sensory, mixed 5, 7, 9, 10. Forebrain divided into telencephalon and diencephalon, right? Telencephalon, cerebral hemisphere, olfactory cortex, right? And the lateral ventricle and third ventricle. This is cranial 1, olfactory, which will be in association with it. Diencephalon, cranial now, number 2, optic, thalamus, and hypothalamus. Obviously part of third ventricle also. That's how it takes. Midbrain, mesencephalon, right? We have got the cranial nuclei 3 and 4 at this level. So structures like tectum, cerebral aqueduct, red nucleus, substantia nigra, crus cerebri, few important structures. Hindbrain, very nice. Metencephalon and the myelencephalon. Metencephalon, pons and cerebellum. Pons front, cerebellum back. Medulla oblongata, that is from the myelencephalon. 5, 6, 7, 8, 9, 10, 12. Right? These are the cranial nerves associated with it. So here it is, right, where we draw cerebral hemisphere. It takes over the diencephalon. So this is telencephalon. It takes over the diencephalon. So entire thing properly covered up. Frontal lobe, parietal lobe, occipital lobe, temporal lobe, and in between is the insula, that's the pons and cerebellum. Pyramidal tract, that is on the anterior aspect. Medulla oblongata is on the back. So here is the central sulcus or Rolandic sulcus, right? And In front of it, it is the motor area. Behind it is the sensory area. And this is pre-gyrus. And after that, it is called as the post-gyrus. There is parieto-occipital sulcus. Lateral sulcus. On the floor of lateral sulcus is the insula, which is for expressions, taste, risk reward behavior. All the pain pathways, they are carried by it. Listening, balancing, and the awareness of the surrounding. That is what is handled by the insula. Right? So that's it for today. See you on Monday. Wish you a very happy weekend. Putting this file into our shared folder. Okay. Thank you and bye-bye.